Yeah, 2004, number 5. It was due like it was due Monday. It's Thursday today, so you should have it done by now, or at least attempted. The graph of the function f shown consists of a semicircle of 3 line segments. Let g be the function given by g of x equals the integral -3 to x f of t dt. Guys, fundamental theorem of calculus. I guarantee it's going to ask for some derivatives. I guarantee it's going to ask you to use initial condition somewhere. All right, here we go. First thing is find g of 0 and g prime of 0. All right, guys, g of 0 is pretty easy, right? For letter A, you plug it in. And we know that the integral from -3 to 0 is the area under the curve. All right, so I look at the graph up here. 1, 2, 3. I see a quadrilateral. You guys agree? Triangle and a rectangle is how I would do this. All right? So I would go equals, and I would say, here we go. I see a triangle that is 1 and 1, and the base is 3. All right? So what I have is 1/2, 1 times 3, plus 1 times 3, all right? I get 3 plus 3/2, which is 4.5. And I'd write it as 9/2 because that's what I do. 4.5. All right? G prime, now this is the key. If I take g of x equals -3 to x f of t dt. G prime of x is simply f of x this time, guys. Right? Because the derivative of x is times 1, right? It's not like it's x squared up there or something, right? Fundamental theorem of calculus. So all I got to do is go to the graph, which I accidentally lost off the screen, right? And at f of 0, or g of 0, I want g prime of 0. So g prime of 0 equals f of 0. So the value at f of 0, you guys agree, is 1? So this equals 1. Give yourself a point for 9/2. Give yourself a point for 1. That's all there is to it. 2 points. Really fast. Yeah. All right. Letter B. Letter B. Find all values of x in the open interval -5 to 4 at which g attains a relative max. Justify your answer. They want to know where g of x is the max. Well, guys, we want to know where a maximum occurs when g prime, right, goes positive to negative. Let's say that again. A max is going to occur when g prime goes positive to negative, right? First derivative rule. And from the previous problem, guys, we know that g prime of x is equal to f of x. You guys agree? From letter A. So, where does it go positive, negative? I think it only goes positive and negative at one spot, guys. Right there. Because we're reading the value. Here it goes negative to positive. That's not the right spot. Here it goes positive to positive, which is not a max. So the only max occurs here at x equals 3. Whoops. So at x, I don't know why my board do this. At x equals 3, f of x goes positive to negative. Thus, a relative max. And again, it could they have used the word local? Sure. This time they used relative, right? We have to be able to flow. All right, guys, 2 points. One for x equals 3, one that you talked about f of x going positive to negative. Seriously? And again, if you get good at this, just a few seconds. And this is why we have to understand the first derivative rule. All right? So we knew it, we had to use the derivative, and that's all there was to it. So you're 4 points in, that means there's 5 points for C and D. find the absolute minimum value on G on the closed interval. Oh, that's cute. Do you guys catch the difference between B and C? What's cute about that, the reason I said that is letter B was on an open interval. You didn't have to check the endpoints. When you look at letter C, what have they done to the interval? They closed it. So now we have to not only use first derivative rule, we have to use extreme value theorem. We got to check our endpoints. All right, we got to check our endpoints. So one thing I would identify as a possible absolute min at, and again, negative to positive. I'm thinking of the curve, right? Negative to positive will make a min. So I look there, and you guys agree it happens at x equals -4? All right, must check endpoints. Uh-oh, my kid's in trouble. Let's check endpoints at x equals -5 and at x equals 4. You guys agree? So now we have to do the function, all right, at those three values, guys. So this is why we got to fly through A and B, because this is going to grind. We got to grind here, all right? Especially since it's no calculator. All right. I'm going to start with G of -5 and work my way left to right. And I'm going to have to make this smaller to give myself some room. So I know I got to check those 3 points. I'll make that small. I'll start with G of -5. And that's going to be the integral from -3 to -5 f of t dt, which is the opposite, because I want to go left to right, right? F of t dt. Oh, how cool is this? You guys see this? The triangles are exactly the same size up and down. You guys see it? So the answer to this is G of -5 is 0. Because this area is negative and this area is positive. All right. Next point I got to check, all right, is G of -4. And I'm, again, just trying to keep a view of the graph in the smartboard here. So I'm going to make this small, set this over here. We'll go to a different color. G of -4 equals, and maybe I would do this right away, guys, to save a little time. I would reverse the integrants and change the sign immediately. All right. And you guys agree that's the rectangle? 1/3. So I get that G of -4 is -3/2. All right. No, that's not 3 tall, guys. It's 2 tall. I read the wrong number. How about -1? Okay. So G of -4 is -1. And then finally, I got to do G of +4. And I suppose, yeah, there's not much to be gained by doing the fundamental theorem of calculus, guys. But I could use my answer for G of 0. Guys, you agree? You guys agree? I don't have to do this. Remember, from our very first problem, you guys remember? Our very first problem, we calculated this area to be 9/2. You guys recall? So I'm going to say this. I'm going to write this. All right? That starts at -3, so I know this was 9/2 for my first problem. Oh, and this is kind of ugly, right? So I might, here's what I'm going to do. You guys agree that the semicircle is positive? All right? You guys agree with that statement? And do you guys agree that there's a positive triangle? All right? That there's a positive triangle, and the integral from here to here, right? The integral from 2 to 4, f of t dt, is 0. You guys see that? Well, here's what I can show then. If I just do it this way, I can say g of 4 is greater than 0. You guys agree with that statement then? I did not get a value. I didn't waste my time to find the area. I might go back and do that, and if you do, I have it written down. If you figured out the area and you have time, that's probably preferable. But it ends up being 13 over 2 minus pi over 2. Point is, it's obviously positive, and we're looking for the absolute minimum. So the absolute so the answer is not negative 4. All right? It says find the absolute minimum. It is not x equals negative 4. Absolute minimum is negative 1. The value, guys, the value. And you wonder why, this is why I'm a complete ogre about that on quizzes, right? Holy cow, big problem. All right, I had to go quite fast. Yep, I started grading it, putting in grades last night. Identifying x equals negative 4 as a possible point is 1. G of negative 4 equals 1 is worth a point. And then saying the absolute minimum is negative 1, and you justify it by showing that you did the extreme value theorem. You've got to show the endpoints, guys. You just can't have this and go to this. You have to show g of negative 5, and you have to show g of 4 being greater than negative 1. Does everybody follow? 3 points. I'm sorry, what, Sam? I had one more come in last night. I'll have them tomorrow. All right, last one. Find all values of x in the open interval, negative 5 to 4, at which the graph of g has an inflection point. All right, first thing I would write is we know that g prime of x is equal to f of x. So do you guys agree that g prime of x is equal to f prime of x? All right, let's be clear about this. This is where it really raises up. A point of inflection happens when the second derivative changes sign. So I'm going to go to the graph, and I want to know when g prime goes positive to negative or negative to positive, right? You don't have to write this on the AP, but I want to make sure, because usually this is what gets us. I start at negative 5, and I see that the slope is positive. Now we're looking at the shape of the curve, right? We're looking at f prime. So positive to negative. All right. Positive to negative, x equals negative 3 is 1. Negative to negative here, guys. No change at 0, right? Nothing there, okay? No. But here it is, negative to positive, all right? At x equals 1. And then the last one, guys, I'll do in purple. Positive to negative at x equals 2. All right? So x equals negative 3, 1, and 2 are points. It says find all x values. Are they, and everybody, if you had all 3 values right, you get 2 points. If you're missing 1, you lose a point. If you're missing 2, you lose 2 points. So if you had 1 of the 3, you got nothing. If you gave an extra 1, you lose a point for the first extra. So my example would be if you put 0 here, you'd get 1 point. Or, but again, change in sign. And remember, you have to go all the way through. Often students screw up and give negative 4 and 1 and 3, right? They use the zeros on the graph. We're not reading the zeros, we're looking for change in sign. You get a 3.